All right, guys, here's a video on the practice test 4A. And on this particular video, we're focusing in on specific sections like solving quadratic inequalities by graphing, that's 4.8, and also 4.2. Of course, there's other videos that explain the other parts of this practice test, like 4.1 and 4.7. Let's jump right in. Right here, we have a question that says, select all the following true statements. So let's analyze what each one of these say. It says if the a value of a quadratic equation is negative, the parabola will have a maximum value. Well, if your a value is negative, that means that it will open down. So you have any type of parabola opens down if your a value is negative. And of course, it's going up, up, up from one side to another till it reaches a maximum height, then it goes down. So this is definitely a true statement. You want to select that one for sure. Moving on. A quadratic equation will always have two solutions. Well, I hope we remember that, actually let's jump to this one since this is true. An x-intercept or x-intercepts, they are solutions, they are roots, they are answers, they are real zeros, all mean the same thing. This is absolutely true. We had this in our notes during class where we made a list of all these words, x-intercepts, solutions, roots, answers, real zeros, they all mean the same thing. Anyway, if we know that x-intercepts are answers, they are solutions, when we look at any parabola, yes, if we find those x-intercepts, whatever those values may be, like this one may be x equals -1, this one may be x equals +2, these x-intercepts are the answers. So right here it says a quadratic equation will always have two answers. Well, in this case, yeah, you do have two answers. But what about in the case of, let's say, this green parabola that just touches once? That one only has one answer, right? Or what about the case of this yellow parabola that opens up here and that never touches the x-axis? That would mean that it has no solution. So this is definitely false. A quadratic equation will always have two solutions? No. I mean, yeah, sometimes you'll have two solutions, but sometimes you'll only have one, or sometimes you won't have any solutions, right? So don't select that one. Moving on, to find the x-intercepts of any parabola algebraically, we must set y equal to 0 and solve. Okay, to find the x-intercepts of any parabola algebraically, we must set y equal to 0 and solve. That is a true statement. Now, I know that we could look at the graph of a parabola and visually say, oh, the x-intercepts are right here at -1 and at +2. But it's not saying visually, it's saying to find the x-intercepts of any parabola algebraically, using algebra. Right? So whatever your equation is, you must set the y equal to 0 and solve. That's true. We also jotted this down in our notes in class that to find the x-intercept, we set y equal to 0. To find the y-intercept, we set x equal to 0. So those are good things to review. This is a true statement. Okay. Moving on, the solutions to a quadratic equation are the x-intercepts of its graph. Yes, because we know that solutions, answers, real zeros, roots, they all mean the same thing. That is true that the x-intercepts are the solutions, right? And again, it's emphasized right here in this statement that the x-intercepts are the solutions. Okay, so that's also a true statement. Keep in mind, because this is a practice test, I will be changing some words. So for example, if I did say, the solutions are the y-intercepts, that's false, right? What are your answers? Your answers are your x-intercepts, not the y-intercepts, all right? So I will be changing some words, so please read carefully and don't read too fast. Let's move on. I love this one. We actually have to type in our answers, but let's read this. It says, given that the parabola is this, y equals, see, it's in vertex form, right? +3, -1, that's a vertex. There's your h, your k, your a value is 1, yep, 1, 1, 2, 4, 3, 9, that's right. Given that this parabola is this equation, it says solve the equation this. Well, notice it's the same thing, the binomial squared -1, binomial squared -1. Instead of equals y, it has equals 0. And that's exactly what you would do to find the x-intercepts, right? The x-intercepts. You would set the y equal to 0 and solve. So you'd end up with this equation and you would solve it. But you don't have to solve it algebraically because you have the graph right here and you could clearly see that the x-intercepts are x equals 2, x equals 4. And that's it. That's your answer. Okay, x equals 2, x equals 4. And I do give you the instructions. Type in your answers with no spaces between terms. I mean, you might have one answer, you might have no solution. If you have two answers, type in with a comma like this, x equals -8, comma, x equals -9, no spaces. That's how you're going to type it in. That's how I wrote it down here. X equals 2, comma, x equals 4, no spaces between your terms. That'll be the correct answer. Moving on. It says solve the above quadratic equation, state the x-intercepts, right? So the other one was easy because if you have a graph. Now this one, you don't have a graph. So since we are dealing with graphing, I recommend sketching the graph. Okay, so let's sketch the graph. What do we know? That the vertex is, think opposite on h, take k for what it is. So the vertex is 1, 2. So let's go to 1, 2. 1 on the x, 2 on the y. Here's the vertex. Now, does this open up or down? It opens down because the a value is negative, and it's also 2. So we know that when your a value is 1, you could use a pattern 1, 1, 2, 4, 3, 9. But we know that this a value is not 1. It's not 1, it's actually -2. So we need to modify this pattern by multiplying the outputs by -2. Or you could just multiply it by a regular 2 and just make sure that you know that it's opening down because it's negative. It's totally up to you. Anyway, when I multiply 1 times -2, that'll give me a -2. When I multiply 4 times -2, that'll give me a -8. When I multiply 9 times -2, that'll give me a -18. So my new pattern is 1 over 2 down, and then go back to the vertex. 2 over 8 down, and then back to the vertex. 3 over 18 down. So with that said, again, this is just a sketch. If I go 1 over and 2 down, I'll be right here at the origin. So let me put a dot right there. And then, yes, I could go 2 over and 8 down, but this is not a real graph that I need to, they're not asking me to graph. They're asking me for the solutions. They're asking me to solve. And we know that solving or finding the answers, the solutions, is the same thing as finding the x-intercepts. So I have an x-intercept right here. Let's also recognize that there's an axis of symmetry right through that vertex. And we're going to map that x-intercept over to the other side. And we end up with this parabola. Yes, it's kind of narrower because it got vertically stretched by 2. It's opening down. But we do know that it crosses right here at the x value of 0 and at the x value of 2. So the answers are 0 and 2. So we're going to actually type in x, we're going to type in x equals 0, comma, x equals 2. And again, when you type it in, don't put any spaces between the terms. X equals 0, comma, x equals 2. No spaces anywhere. Okay, that's going to be your answer. It doesn't matter if you put the 2 first or the 0. It should still work. All right, here's another one where we don't have the graph and they want us to solve it. And we should know that when they ask us to solve to find the answers, it's the same thing as finding the x-intercepts, right? I even write that out for you. So let's sketch a graph. That's an xy plane, and let's go to our vertex. Think opposite on h, take k for what it is, so that's -3, comma 1. So if I do go to -1, 2, 3, and +1, I'll be right here. And from there, this thing opens up because the a value is positive. Not only that, it gets vertically stretched by 5, so we know that this is pretty narrow. This is a very narrow parabola opening up, okay? So we are trying to find the x-intercepts. Where does it cross the x-axis? The answer is that it does not cross the x. So what do we say? We say no solution. No solution. And on the instructions it says if you have no solution, go ahead and type in NS, just capital N, capital S, boom, that's your answer. I love this one because, again, like the other questions on this practice test, they're asking us to solve. And what does solve mean? Finding the answers is the same thing as finding the x-intercepts. So let's sketch this thing. Once again, the vertex is, think opposite on h, that's a -6. Take k for what it is. There is no number over here, so technically that's a 0. And if you go to the coordinate -1, 2, 3, 4, 5, 6, 0, that is right here. And from that point, it's opening down because the a value is negative, and it gets vertically stretched by 3, so it's pretty narrow, opening down. Well, that's really ugly, but you get the idea. The only thing you really care about is the x-intercepts. And where does it cross the x-axis? It only touches right here at that value of x equals -6. So this one does not have two answers. And it does say if you have two answers, type it in like this, but it's only one answer, so please type it in with no spaces between your terms. So you're going to just type in x equals -6, no spaces anywhere. Hit enter, and you should get full credit right there on this one. I love these right here. We're graphing parabolas that are inequalities, not equations. And this one's really simple. It just says select which one of these represents this quadratic inequality. So let's go with what we know. The easiest quadratic equation to write would be in vertex form. And of course, when we use vertex form, let's rewrite it, but with blank spots, and just plug in our a, our h, and our k. So the question is, what is the a value? Well, we know that the a value of 1 would give us the pattern 1, 1, 2, 4, 3, 9. So let's verify that. Does this have the a value of 1? Does it go 1, 1? Yep. 2, 1, 2, 3, 4. Yep. I don't even have to check the last one, 3, 9. But if I already know that these two are according to this pattern of a equals 1, then we know for a fact that the a value is 1. What is the hk value? Well, the hk value is pretty easy. It's just the vertex. -1 on the x, -4 on the y. So the hk, or actually let me write this out. The vertex is -1, -4. So your h is truly -1. So you put in a -1, exactly the way it is. And the k is -4. And of course, all we got to do is clean this up to make it look nicer. So what we have is y equals, you don't need the 1. The minus minus changes to a plus plus, so you really have x plus 1 in parentheses squared. And the plus minus 4 you don't really need, just put a -4. So this is your quadratic equation, but this is not an equation, okay? This is an inequality, all right? So let's put our pencil on the graph itself, okay? Are we shading above or below that vertex value? We're shading above, right? On any point, even if you pick this blue point, where is it shaded? It's above. See, that's how you get to the yellow. Not below. There's nothing shaded down here. So it's either above or below, and this is clearly above. So this should be a greater than, not greater than or equal to. It should just be a greater than symbol. So let's actually put that in, greater than. And that is the reason why it's a dotted parabola. If it were a solid parabola shaded up, it'd be a greater than or equal to, because that would be solid if it were an or equal to. A solid graph would mean that you have to have a solid line underneath your inequality. So as we could see, this one is not it, and neither is, oh no, this one is it right here. There's your answer. Oh no, it's not. Why is it not? Be very careful. You see, I almost got tricked right there. This is a greater than or equal to, which would make it a solid parabola, and we know that this is not solid, it's dotted, so it should just be greater than. So in reality, none of these are correct, okay? So man, that was tricky right there. That is definitely not it, right? Let's move on to another one. All right, I love this one because they give you the graph, right? Love it. What do I mean by that? Well, first of all, they're asking you to state the following solutions to the quadratic inequality 2x squared plus 4x is less than or equal to 0. You could solve this algebraically, and we will be solving this algebraically in the future, but they give you the graph. Look, it's the same exact quadratic binomial, 2x squared plus 4x, 2x squared plus 4x, but they give you the graph of it, all right? So what do we know here? We know that this is a solid parabola. We know that it's in standard form. The c value is 0, which means that it does have the y-intercept of 0. Okay, that's great. We understand this parabola. We know that it's shaded above any point that you pick. If you pick this point right here, where are you going to shade, below or up here? It's above. So that's why it's a greater than. Because it's a solid parabola, it's a greater than or equal to. So we understand this. We know this parabola is represented right here with this graph. And they're asking us to find the answers of this. Now, what we need to understand here is that when they give you a quadratic inequality and it just has x's, there is no more y, right? The y got set equal to 0. So you're just talking about the x values. And if you zoom in and just look at the x number line, okay, let's zoom in and just look at the x number line. You know what? Maybe I need to do this. Let me, I'm going to put a rectangle up here, like that. And also I'm going to put a rectangle down here. So just looking at the X number line, where are your answers at? Where is your shade at? Well, it's a solid part of the parabola right here. It's a solid part of the parabola right there. And the answers are where? They're inside right here. Okay, so the answers are inside. It's a area that's together, not apart. So that's going to tell us whether we're going to write this thing together or apart. So ignoring the whole thing, just focusing in on the X number line, you have to write this as a compound inequality together from the point -2 to the point 0. So how do we do that? You simply put X in the middle and then put less than symbols. But then because this is a solid parabola, you're going to put or equal to. So there's your compound inequality answer. -2 is less than or equal to X is less than or equal to 0. Now, if this would have been a dotted parabola, then you would have just used the less than symbols, you wouldn't put a solid line underneath your inequality. But if it would have been shaded on the outside, which will have problems like that, then it would have been X is less than -2 or X is greater than 0. You'd have to write the two inequalities separate with the word or. In this case, it's an area that's together. So that's why this answer is right here. This is your correct answer. Moving on. On this one, they give us this quadratic inequality. They want us to solve the inequality. But then it says, tip, think of the graph of this, right? Because as you can see, this is in vertex form. The A value is 2, H is 3, K value is 1. And it's the same exact vertex form quadratic inequality here. So let's think about the graph here. Let's actually sketch it. So here's our xy plane. The vertex is at +3, +1. So if we go 1, 2, 3, 1, this will be a dot right there. And we do know that this opens up, right? It opens up because the A value is 2. So it's opening up and it's vertically stretched by 2. So it's a little bit narrower than usual, but it's opening up. Now the question is, well, maybe before I shouldn't have actually drawn it. Okay, let me actually erase this because I need to know, there's my vertex. I know it's opening up, I know it's vertically stretched by 2, but is this going to be a solid parabola or a dotted parabola? Obviously dotted. So just to stay accurate with my sketch here, even though it doesn't have to be perfect, it's a dotted parabola, okay? In addition to that, I need to shade because it's an inequality. So I need to put my pencil on any part of this parabola. I'm going to go on the vertex, and I need to decide, do I shade above, which would ultimately be on the inside of the parabola, or do I shade below, which would be on the outside of the parabola? And since this is a less than symbol, you're going to be shading below. So when you shade below, you end up shading everything that's on the outside of the parabola, not on the inside of the parabola, okay? Now, since we are trying to solve this quadratic inequality, which pretty much has the y set equal to 0, you're looking for x-intercepts, right? But we're talking about the shaded area. That's where your answers are at, okay? So what part of the x-axis is shaded? Is it just from like 0 to 4? Or is it, 0 to 4, is it from 1 to 3? I don't know, but actually I do know the shaded area is all of the x-axis. Every single part of the x-axis is highlighted because I shaded below that parabola, okay? Now, yes, there will be some that they're down here and you shade the inside and it's only from here to here, right? You do a compound inequality, or maybe there's a parabola like this and these are your x-intercepts and you shade on the outside, so it would be two inequalities separate with the word or. Right here, where is it highlighted? All of the x values are highlighted, which means x equals all real numbers. Any number on the x-axis will be shaded, which means that any number on the x-axis is a solution, which means x equals all real numbers. There is your answer. Given that the above graph, well, technically it's below, is y is greater than x squared minus 2x minus 3. I mean, you could, if you wanted to, verify that this is it, but that'd be a waste of time. I'm letting you know that this parabola is represented with that quadratic trinomial inequality. You could, if you wanted to, go x equal, or x equals negative b over 2 times a, and find the x value of your vertex, and then you can plug it back in to find the y value. You will get that -1, -4 vertex. But that's, again, a waste of time because I'm letting you know that this inequality is represented right here, makes total sense, greater than is above any point in the parabola. And they want you to state the solutions to this exact quadratic trinomial, but that is less than 0. Now that makes total sense because if I wanted to find the x-intercepts, if I wanted to find the solutions, I would have to set y equal to 0 and solve. So imagine this y becoming 0. That'd be 0 is greater than that stuff. And right here is exactly that. 0 is greater than that stuff. All I did was rewrite the 0 that's greater than on the other side. There it is, 0 is greater than. So obviously when it's on the other side, it looks like a less than symbol. Anyway, we want to solve this, and in the future we will be using algebra. In this case, let's use this graph, and of course the area that the solutions are at are between the x value of -3 and 1. So the area is right here. It's on the inside, pointing towards each other, right? So how do I write this as a compound inequality? You're going to type in the number on the left, -3. You're going to type in the number on the right, 1, and you're going to put the x in the middle, and you're going to put less than symbols. If this were a solid parabola, you would put solid lines underneath the inequality, but in this case, this is your compound inequality answer. So down here, well, it does say type in your answer with no spaces between your terms. So this is what you would type in. -3 is less than x is less than +1. Alrighty, I love these where they give you a graph and they ask you to, you know, I've been thinking, I say I love these all the time. I love math. Anyway, these are pretty simple because all you have to do is create your parabola given the information that you could see. So all you need is an a value, you need an h value, and you need a k value. And once you have that, then you could write it in vertex form, which is y equals a parentheses x minus h close parentheses squared plus k. Anyway, we do know our vertex, which is right here, and that is the coordinate 3, -4. So that's your h and your k. So what about the a value? The a value, well, we know if the a value is 1, we should have the pattern 1, 1, 2, 4, 3, 9. If the a value is 1, that's the pattern that we would use. So do we have that pattern? Yes, we do. 1, 1, 1, 2, 1, 2, 3, 4. Back to the vertex, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. Yep, this is absolutely the a value of 1. So let's plug in our a, h, and k into the vertex format. Again, the a value is 1, the h value is 3, and the k value is -4. Let's just clean this up a bit. What do I mean by clean it up? Well, it's not necessary to have a 1 out there. Let's just put parentheses x minus 3 squared. And then the plus -4, you don't really need a plus -4. You could just put a -4. So one other thing, this is not a regular parabola. It's an inequality. So we either shade above or below, and that should replace this equal sign. So let's erase the equal sign, and let's ask ourselves, is it a greater than symbol or is it a less than symbol? Any point on the parabola, is the shade above the point or is the shade below the point? Obviously it's below. That dot below is shaded. The vertex below is shaded. This dot below is shaded. So this has to be a less than symbol, okay? And it's not a less than or equal to, it's just a regular less than. If this would have been a solid parabola with the shaded below, then it'd be a less than or equal to, but it's a dotted parabola, so it's not solid. You don't put a solid line underneath your inequality. Anyway, that's your inequality right there. Let's look for it. We have y is less than x minus 3 squared minus 4. Y is less than x plus 3. That's incorrect. Oh, here it is. Oh, wait a minute. Greater than or equal to. And that's greater than would be above. So that's definitely all wrong. So these two vertex form equations are not it. But we know that this one is it. And the other two options that they give us are in standard form. So what we need to do is actually change this to standard form and see if one of those is our standard form inequality. Or another option would be to find the vertex, x equals negative b over 2 times a, and then get that value, plug it in, and find your y value, and then see if that vertex really does give you a 3, negative 4. But that's work right there and right there. You might as well take the equation that you already know that is in standard form, and let's just vertex form, and change it to standard. How do we do that? By doing the math, right? We know that standard form doesn't have parentheses. So we have in parentheses x minus 3 to the second power. So what we need to do is actually work that out. X minus 3 times itself. And we're going to distribute x times x squared, x times negative 3x. Negative 3 times x is another negative 3x. Negative 3 times negative 3 is positive 9. Let's not forget about the minus 4 that's out here at the end. So after multiplying, after distributing, which is really multiplying, we are going to combine the terms that are alike. I want to combine this negative 3x with that negative 3x. If I owe somebody $3 and I owe somebody else $3, I owe a total of 6 of those dollars, in this case x's. What about this 9 minus 4? 9 minus 4 is a positive 5. And let's not forget about the x squared in the front. Let's bring that down. Ladies and gentlemen, here is our inequality. Y is less than x squared minus 6x plus 5. Y is less than minus 6x, x squared minus 6x plus 5. Y is greater than x squared minus 6x plus 5. Y is less than x squared minus 6x plus 5. So this is your correct answer right here. Alrighty, the instructions say use the above graph, which is down here, of the inequality y is less than x squared minus 6x plus 5. So I'm giving you the actual graph of this inequality to state the solutions to this inequality. Now notice that it's the same exact inequality or same exact quadratic trinomial that's in standard form, ax squared minus 6x, or x squared minus 6x plus 5. There it is, x squared minus 6x plus 5. If I were to ask you to find the x-intercepts, right, the solutions, if I'm asking you to solve, you would set y equal to 0 and solve. So you'd have 0 is less than that quadratic trinomial, and there it is, 0 is less than that quadratic trinomial. It's just read backwards. So in this case, we have that quadratic trinomial is greater than 0. So instead of solving algebraically, we could just look at the graph and state where the answers are at in terms of x, right? In terms of your x-axis, your x number line. All right, so where are your answers at? We have an open dot right here shaded this way, and we also have an open dot right here shaded that way, okay? This is obviously on the original a less than, so you shade below, shade below, shade below. Now when I say shade below, what I'm really doing is shading the outside of the parabola, shading everything on the outside of the parabola, okay? Now again, when we're dealing with the inequality without the y, where we set y equal to 0, we're just worried about x's, and we're looking at the x number line only. So ignoring everything else, it's an open dot here going that way. So what inequality represents an open dot going this way from the x value of 1? You're going to say x is less than 1, okay? And then how do you represent this other one that has an open dot at 5, and going that way? Well, that would be x is greater than 5, okay? So if they are going apart from each other, it's either going that way or that way, so you write both of them with the word or between it. If the areas would have been together, if it would have been shaded on the inside, you write the area together as a compound inequality with x in the middle, smaller number on the left side, bigger number on the right side with less than symbols. But these are apart, so it's going that way or that way. So we're going to say x is less than 1 or x is greater than 5, and that is your answer right there. X is less than 1 or x is greater than 5. Alrighty, so on this one, we have the quadratic inequality. Y is less than or equal to. The or equal to means solid parabola. Less than means that we're shading below, so that's exactly what this is. If you wanted to, you could find the vertex x equals negative b over 2 times a. You will find that the x value is positive 2, and if you plug it in, it'll give you the y value of negative 1. So this is all accurate, but they're telling you to use this quadratic inequality, which is shown right here, to state the solutions to this inequality, which is the same exact quadratic trinomial, but obviously the y value set equal to 0. That's why it says 0 is less than or equal to. 0 is less than or equal to. But if you read it backwards, it says that this quadratic trinomial is greater than or equal to 0. Anyway, what are the solutions? The solutions are down here. Now remember, you want to state your solutions. Solutions are x-intercepts. The solutions are the x values. So with regards to the x-axis, where is the shading at? Is it between 1 and 3 right here? Is there any shade in there? No. Is it all of these numbers? Is everything shaded out here where all of the numbers on the x-axis would be included? So you would say x equals all real numbers? No. Is there any part of the x-axis that has a shade on it? No. So this is one of those cases where there are no solutions, right? Or maybe I should do it in green. We always use green for the answer. So this is a no solution problem. Now, if it would have been shaded on the outside, then all of your x values would be in the shade, which means all of your answers would be solutions, which means you would say x equals all real numbers. But of course, the shade is below the parabola, so it'll never touch the x-axis, which means it has no solutions, even on this inequality. So here we have another parabola, quadratic inequality. It is in vertex form. We could clearly see that that is the vertex, -2, +1, opposite on h, take k for what it is. This is slightly wider because it got vertically compressed by 1/2. It is dotted because it doesn't have a solid line underneath the inequality. So I tell you, use this graph to show the solutions for x on this inequality. So we already know that it's shaded below the parabola, which means that it's shaded everywhere on the outside, which means that the whole entire, any x value on the x number line, -3 is in the shade, -1 is in the shade, -10 is in the shade, +10 is in the shade, any x value will be in the shade on the x number line. So that means that x equals all real numbers. So there's your solution for that one. Here we go, guys. This one, they give you the inequality and they want you to solve it, and you could solve it algebraically, but I tell you, think of the graph, because it is in vertex form, right? So this is the same vertex form inequality. So knowing your solutions is really knowing your x-intercepts. And this will be a shaded parabola. It will be a dotted parabola because it's an inequality that does not have a solid line underneath it. Let's actually sketch it so we could see where our answers are at after shading. So we do know that the vertex is -1, +4. So the vertex, -1, +4. So there is my vertex right there, okay? -1, +4, -1 on the x, +4 on the y. We also know the axis of symmetry. That just goes right through the vertex. And if I wanted to, might as well, let's just practice. What is the axis of symmetry? It's x equals -1. You don't have to write that down, but just maybe a different question in the future will ask you that. So there you go. The axis of symmetry is x equals -1. In addition to that, we know that the a value is -1. Okay, so the a value is -1, which means that you could use a pattern 1, 1, 2, 4, 3, 9. Just remember that it's opening down. So when I go 1 over 1 down, I'm going to put a dot right there. I want to use blue so it could stand out a little more. And we're also going to have to go back to the vertex and go 2 over and 4 down. 1, 2, 3, 4. I'll end up right there. I'm going to use another blue dot right there. And of course, we have our sketch of our parabola. Let's reflect it over to the other side. So this one is 1 unit away. So let's go 1 unit this way, 1 unit that way, and put a dot at that same level. That'll be a dot right here. And then this one is 1 unit, 2 units away. So let's go 1 unit, 2 units away, and put a dot right here. And ladies and gentlemen, we have our parabola. Wait a minute, I'm drawing this wrong because it should be a dotted parabola, not a solid parabola. So let me erase some stuff here. Let's make this dotted using whiteout. How's that? Pretty cool, right? Okay, so it's dotted. Now the question is, do I shade above or below this dotted parabola? And we should all know that because this is a greater than symbol, we're going to be shading above. So you could put your pencil on any part of this graph. Let's go on the vertex. you're going to shade above any point on the graph, shade above, shade above. So obviously we are shading the outside of this parabola, okay? Shading the outside of this parabola. So in terms of your x values, because they want the solutions, and on this inequality, it's just all about x. What does x equal? Where are your answers at? It's in the shaded area. So with regards to your x-axis, it's at an open dot right here going this way. It's at an open dot over here going that way. How do I know it's open dots? Because this is not a solid parabola. So because it's an open dot going to the left from the x value of -1, 2, 3, that's going to be x is less than -3. That's one answer. And the other answer is x is greater than +1. Now, of course, you need the word or right between them. So there's your answer. X is less than -3 or x is greater than 1. You need the word or between them because the areas are going apart. They're either going that way or that way. So when you type it in, it says right here, type them in like this. X is less than -7 or x is greater than -8. It says with the word or between them and no spaces between your terms. Or if it would have been an area that's together, then you would have typed it in as a compound inequality. Of course, if there would be no shade touching the x-axis, that would be a no solution. Or if the entire x-axis was shaded, then it would be all real numbers. In this case, it is simply x is less than, so this is how you would type it in, x is less than -3 or x is greater than 1. Okay? Type it in, no spaces between your terms.